The Nine-Point Circle Theorem. Complete proof inside the triangle. A, B, C vertices of the triangle. O circumcenter, the center of the circumcircle. H orthocenter. H sub A, H sub B, H sub C feet of the altitudes. M sub A, M sub B, M sub C midpoints of the sides. E sub A, E sub B, E sub C Euler points, the midpoints of AH, BH and CH. N midpoint of OH and the center of the 9-point circle. Green circle, the 9-point circle with the center N and radius R/2. In this lesson, we are going to prove one of the most beautiful theorems in geometry, the 9-point circle theorem. Stay with me until the end of this video, and you'll see the complete proof step by step. Key lemma, Euler vector lemma. Place the origin at O. Let the position vectors of A, B, and C be vector A, vector B, and vector C. The magnitude of vector A is equal to magnitude of vector B and equal to the magnitude of vector C, and they are all equal to R. Then the position vector of H is equal to vector A plus vector B plus vector C. Proof: vector AH is equal to vector H minus vector A, which is equal to vector B plus vector C. Vector BC is equal to vector C minus vector B. The dot product of the quantity vector B plus vector C and the quantity vector C minus vector B is equal to the magnitude of vector C squared minus the magnitude of vector B squared. This is equal to R squared minus R squared, which equals 0. Therefore, line AH is perpendicular to line BC. Similarly, line BH is perpendicular to line CA, and line CH is perpendicular to line AB. Hence, H is the orthocenter. Center of midpoints of sides. Let N be the midpoint of OH. Since O is the origin, the position vector of N is equal to the position vector of H divided by 2. The position vector of H divided by 2 is equal to the quantity vector A plus vector B plus vector C, all divided by 2. The midpoint of BC, M sub A, has the position vector equal to the quantity vector B plus vector C divided by 2. Then, the position vector of N minus the position vector of M sub A is equal to the quantity vector A plus vector B plus vector C divided by 2 minus the quantity vector B plus vector C divided by 2, which is equal to vector A divided by 2. Therefore, the magnitude of vector N minus vector M sub A is equal to the magnitude of vector A divided by 2, which is equal to R/2. Similarly, the magnitude of vector N minus vector M sub B and the magnitude of vector N minus vector M sub C are both equal to R/2. Thus, M sub A, M sub B, and M sub C lie on the circle with the center N and radius R/2. Step 2. Euler points. Euler point E sub A is the midpoint of AH. The position vector of E sub A is equal to the quantity vector A plus vector H divided by 2. Since vector H is equal to vector A plus vector B plus vector C, the position vector of E sub A becomes the quantity 2 vector A plus vector B plus vector C divided by 2. Then the position vector of N minus the position vector of E sub A is equal to negative vector A divided by 2. Therefore, the magnitude of vector N minus vector E sub A is equal to R/2. Moreover, vector N minus vector E sub A is equal to the negative of quantity vector N minus vector M sub A. Therefore, E sub A and M sub A are diametrically opposite points. Similarly, E sub B and M sub B and E sub C and M sub C are diametrically positive points. Thus, E sub A, E sub B, and E sub C also lie on the same circle. Fit of altitudes using Euler's theorem. Consider altitude AH and its foot H sub A on line BC. Points A, H, and E sub A are collinear on this altitude. Points H sub A and M sub A lie on line BC. Since AH is perpendicular to BC, angle E sub A, H sub A, M sub A is 90 degrees. Because E sub A, M sub A is a diameter of the circle by the converse of Euler's theorem. If an angle subtends a diameter and is 90 degrees, then the vertex lies on the circle. Hence, H sub A lies on the circle. Similarly, H sub B and H sub C also lie on the circle. Conclusion. All 9 points M sub A, M sub B, M sub C, H sub A, H sub B, H sub C, E sub A, E sub B, and E sub C lie on the same circle with center N, the midpoint of OH, and radius R over 2. And that completes the proof. If you enjoyed this geometry challenge, hit the like button and subscribe for more math breakdowns. See you in the next video.